Good morning, everybody. Welcome to our monthly webinar. I like to do this, really, it's for fun, and also to be able to teach lengthy on a certain topic. Today, we're going to talk about immune health. And we do this sort of as a service for everybody. It's just so hard to convey information in a setting in clinic, and sometimes I think people just want to learn. So hopefully that's why you're here and that's why you're watching. If you have questions, feel free to ask. If I'm capable of answering them, I will. All right, I'm Dr. Meredith Warner of Warner Orthopedics and Wellness, and I have a private practice in Baton Rouge focused primarily on musculoskeletal and connective tissue health, but we do a variety of wellness services as well. And one of my big loves is natural medicine, and this started with a focus on wound healing and injury after fractures and things like that in orthopedics, which is what I do. And then from that, I started to treat a lot of diabetics with diabetic foot wounds. And then from that, went into wellness and natural medicine, really because it's all a continuum of immune health functions. So years ago, I learned that wounds heal better, fractures heal better, people heal better after car accidents and whatnot. If they're healthy, if they take certain vitamins, certain micronutrients, they all seem to do better. And I've just delved into that since then. Really, it all comes down to the immune system, whether you're fighting off a virus or healing yourself from an injury or trying to prevent or treat cancer. Almost everything comes down to immune health, and then that comes down to mitochondrial health. And we'll talk about all of that. So this is our office in Baton Rouge, and we try to make it promote a feeling of healthiness and wellness. We have a very large physical therapy gym. As someone that treats the human body, the musculoskeletal system, I think the physical medicine aspect of it is extremely important. Gaining flexibility, strength, balance, reflexes, things like that is vitally important to reducing pain and improving function. So we have a huge component of physical therapy in our clinic. We also offer some podiatry services, aesthetic medicine, physical medicine and rehab, infrared spa treatments, IV therapy, and a variety of other treatments for wellness. To include full workups of people's immune systems and inflammatory burden, because that's a huge problem right now in our society is chronic inflammation, which of course affects the immune system. So today we're going to talk a bit about immune health. Think of this more like a review, like trying to recall what you may have learned in college or high school or med school. But it's extremely important. And I think, especially nowadays, the more you understand about this system, the better off you'll be when talking about it. Okay, so our human immune system is pretty awesome if you think about it. Think about the earth as a big, huge soup bowl that you're walking through every day, and you're just attacked by hundreds of thousands of viruses and bacteria on any given day. Different injuries happen, pollution, everything else. And we're seemingly able to handle this and not just survive, but thrive. And really, it's because of this immune system. It's a two-part system: innate immunity, which means you're born with it, and adaptive immunity, which means your system has to learn it over time. The innate immunity is comprised of all of our first-line defenses, and I'm going to talk about that, sort of our barriers. And then it is just indiscriminate destruction of pathogens. So there's no way to recognize your own cells versus invading cells. They just go off of very vague little signals, I guess, and attack anything, takes all comers. And then because of that, it's very easy to begin a process of friendly fire. So if you think of this in military terms. So innate immunity is that forward operating team that goes out there, but sometimes mistakes happen and you have friendly fire. We don't want that. So the human body has also developed adaptive immunity, and this responds to particular pathogens. So you can actually create a database of memory in your body from being exposed to and encountering certain viruses and pathogens throughout time. This is why you may or may not have heard this. Children that are exposed to dirt and the outside and lots of other kids, and they are always getting sick when they're babies, they tend to be healthier when they get older because their adaptive immune system has been trained and primed and is functioning optimally. Children that are too protected and kept too clean and not exposed to different viruses and pathogens tend to be a little bit more sickly and allergic as they get older because their adaptive immune system has not been primed and trained. So you can create a database of memory cells and antibodies, okay? And then the adaptive immune system responds to the innate immune system, will actually travel through the body to where it is needed when it is needed. and it'll actually harness all of the inflammatory cytokines, all of the proteins for healing, and it'll take the process from attack, attack, attack to clean up, to remodel and make better. All right. So the innate immunity is what we're born with. This is a picture of some of the cells involved. Your macrophages, your neutrophils, which are the white blood cells. That's the majority of what we mostly think of as lymphocytes or white blood cells. Dendritic cells, natural killer cells, which are hugely important in taking out pathogens when they first hit your system. Anyway, let's say you breathe in a load of virus, or you get a cut and it's propagated with some bacteria and you start to get infected like an abscess. At that point, all the innate immune system senses this because the damaged cells release certain signals. They rush to the area. Think of them like the EMS. They're the first responders. They get in there, they try to destroy all the pathogens, they engulf it, they eat it up. They destroy it with certain items called exosomes, which we'll talk about, and then they eliminate the pathogen. Problem is, if you don't control this system, the innate immunity, they go haywire and they never leave, and then they start attacking your own cells. So the innate immune system works very, very closely with the adaptive immune system. I'm going to focus a bit on the innate, and then we'll go to the adaptive. If you look at a picture of the angry green, I guess that's a bacteria or virus. Those sort of Y-shaped yellow things are what you would think of as an antibody. And they have been trained over time by the adaptive system to recognize those items on that virus. And then they will engulf it, involve the innate immune system and other cytokines and destroy it. And then there's a dendritic cell, and then there's a monocyte as well. It's a very complex interplay, and it's almost like an orchestra. So let's talk a bit more about the innate. So this picture shows you the cool picture on the bottom, the electron micrograph. That is a dendritic cell that has sensed badness in those little bacteria, the little orange bacteria, and it's grabbing them, and it's going to engulf them and destroy them. Okay, and then on the top, there's images of your different immune system cells, and I've X'd out the adaptive immune system cells. So the T cells and the B cells are your adaptive system, so humoral and cellular immunity. The rest of those cells are your first responders. So basically, the neutrophil, or the white blood cell, will target the pathogen. Pathogen could be anything, a foreign body, a virus, a bacteria, a parasite. And it'll use what's called chemotaxis, where you release little chemicals to bring in other cells as a signal and also to get closer to the pathogen. And then it will form a little internal balloon and sort of engulf the pathogen and eat it up, almost like Pac-Man, if any of you out there remember Pac-Man. So the little guys are out there, and the Pac-Man comes up and engulfs them. And then when the pathogen gets inside the white blood cell, you actually have little packets of oxidative stress. And you've probably heard me talk about the badness of oxidative stress, but in this case, we want it. That's why it exists in our body. So these little balls of oxidative stress or reactive oxygen species will dump onto the pathogen and destroy it, and then that gets eliminated, okay? Problem is, you don't want these exosomes destroying your own cells or your self cells down the road, and that's when you've developed autoimmunity, or you never get out of a chronically inflamed state. That's why chronic inflammation is so terrible. All right, so let's talk about the innate immune system in its entirety. It starts with walls, the first line of defense, the barrier. So this is your skin. Your skin protects you from a lot of problems out there. Your GI tract, so the lining of your gut, is very protective and has a huge amount of immune system function. So let's say you violate the 5-second rule when you drop something on the floor and you go 6 seconds and you still eat it. Or you're Costanza in that episode of Seinfeld where he pulled the chocolate eclair out of the trash and eats it. At that point, your GI system's innate immunity or the barrier defense is going to protect you, right? It's just going to attack and engulf before it even gets into your system. The respiratory tract, same thing. You breathe in. Cilia, which is the bottom picture here, very important in the respiratory system. That is what brings up mucus and helps you cough. Like when you have either an upper or a lower respiratory infection, these little hairs are always moving and trying to push out yuckiness. And they use what's in the second group here, the defensive weapons or the passive. So think of like a medieval kingdom, and you've got the castle and you've got the walls. Well, somebody's able to get the wall and they're starting to crawl up the wall. What's the next thing they did? They dumped oil, burning oil on them, right? Or shot arrows. So that's your passive defensive weapons. Your mucus, your secretions, your bile, the acid in your stomach. Sweat is a way to get rid of toxins and problems. Tears get rid of problems in your eyes. Saliva spits it out in the mouth, plus saliva has a lot of enzymes that help to digest things. So if the walls fail, you've then got the defensive weapons. So like mucus will help cilia function to protect you from pathogens. And then if it gets past that, that's when your dendrocytes, your monocytes, your basophils, your eosinophils, all of your innate immune defense systems come in. They recognize these things as not self or not human, and they just start to destroy it. And so neutrophils, or polymorphonucleic cells, PMNs, are about 65% of your white blood cells. So sometimes your doctor will order a CBC, sometimes they'll order a CBC with diff. The CBC with diff will actually differentiate the white blood cells into percent of neutrophils, percent of eosinophils, percent of basophils, and that helps us determine if you're having a very allergic reaction to something, you'll have more eosinophils. If you're infected, you'll have a higher rate of neutrophils. It'll be up to like 80 or 90%. So that's why sometimes we order those. The eosinophils are smaller. They respond to parasites and allergic irritants like pollen and whatnot. And then the basophils, very small amount, but very important for fighting parasites, which we don't deal with a lot in the United States, but that's pretty important third world. And then the dendritic cells, the long one with the little arms, they'll grab the badness, suck it in, and then pull it apart, find a protein on the bad guy that they like, put it out on the membrane, and then that is an antigen that can then trigger the adaptive system. Mast cells, another very important innate immune system cell, very important for my purposes, for connective tissue health, muscle health, healing wounds, healing fractures. Also important for allergy and people that get anaphylactic, like I guess when you have a hyper-reactive response to, say, bee venom. And then the macrophages are the large eaters, and these are very important in wounds. So macrophages either have a M1 or M2 phenotype. M1 is hopefully I don't get this backward. M1 is the good one, or chronic inflammation. That's the one that goes when you're trying to do your innate immune response to an initial wound. Sometimes it never turns into the M2, which allows the wound to then remodel and become normal tissue. And so that's when you get these chronic wounds that last year after year after year, because your macrophages never turn and you're always just in that initial innate immune function. And then, of course, the natural killer cells. Which have a great name, but they actually do what they say. They just basically kill whatever they touch. Okay, just quickly about the complement system. The complement system is a series of proteins running around your body all the time that essentially assist or complement your adaptive and innate immune systems. These are evolutionarily maintained, so a variety of different types of creatures on the planet have the same exact system of protection. So when an antibody from the B cells, which we'll talk about, binds to a pathogen, the complement system will get activated, and these proteins will just come in and coat the pathogen and assist in the destruction. It's about 20 proteins, probably more really. And again, it's an assistive system. But if you have certain autoimmune disorders, some of these will go up, some of them will go down, and you can measure dysfunction that way just by measuring the complement system. And these are guided by chemotaxis, or those chemical signals that are given out by the innate immune cells, damaged self cells, or by B and C cells. So right now, while you're watching this talk, you've got complement floating all throughout you, just waiting to help if something gets into your system, waiting to provide more defense capabilities. So think of these like protein bombs, and they're like sleeper cells. So they're present at all time. They've been there. You just didn't know they were there. And they only work when they're activated. So somebody calls them up and says, you're on, go do your thing. That being the chemotaxis from the other cells. And so, for instance, for complement 3, C3, it'll get activated and become C3A, C3B. If it's not activated, it'll get neutralized by water, degrade, go away, and another one replaces it. So these things don't just stay in your system forever. They're constantly recycled, okay? And they once they're activated, they then become other complements. And then when they attach to the pathogen, they signal even more complement proteins. And eventually, thousands of these proteins can coat a little bacteria. You can see that, the red stuff around this little bacteria. And then you see the big Pac-Man coming in, helping the complement destroy the pathogen. So we have the first line of defense, the barriers. We've got the passive, like the mucus and the secretions and the cilia. We've got the natural killer cells and other innate cells. And then we've got the complement system on top of that. So it's surprising we get sick at all if you think about it, right? The problem is when we don't have a system working well. So how do you get your system to work well? You got to have the right micronutrients involved in your system. And I've just listed a few here: vitamin C, D, A, E, and B6. And then you other phytochemicals that you get from a good diet like quercetin really, really help with immune cell function. Okay, so let's talk about vitamin C. Vitamin C is one of my favorite antioxidants. It's a water soluble. So this is going to be more involved on immune cell defense and antioxidant function on either side of a cell membrane, okay? Because the cell membrane is fat. And so the water antioxidants don't really help problems going on in the cell membrane. They really go on the other side. So, how do antioxidants work? The green ball and the blue ball show you what happens when you have an unpaired electron. So, see how around the green ball you've got 2, 4, 6, and then that odd man out on the top. What'll happen is it'll pull an electron from a stable molecule, like a stable protein or a DNA or something like that, and then make that unstable. And that's oxidative stress damage. So now the blue guy has lost an electron and become unstable. What vitamin C does is it'll come in and throw an electron down onto the green guy so that it can protect the blue guy. And then you would think, well, doesn't that make vitamin C lose an electron and make that unstable? Well, the way that the antioxidants molecular structure is, they actually can tolerate the loss of an electron and still remain stable. That's how they work. So vitally important. Why? Because remember, part of the immune system response is a release of oxidative stress and oxidative bursts. And so you may have heard of this term cytokine storm. Well, if you get too much of that going on, you just start to indiscriminately destroy everything, including your own lung cells, your own self cells. Vitamin C can tamp down that oxidative response and help protect your self cells and protect you from that cytokine storm. In addition, vitamin C helps to build barriers, very important for connective tissue, skin, muscle cells, nerve cells. So vitamin C helps collagen cross-link. So anything comprised of collagen will work better with more vitamin C in the system. And then, of course, it helps with the chemotaxis or the chemical signaling and movement of other cells. But I think of vitamin C as really just not just helping your white blood cells function better, but protecting yourself from the bullets that they're shooting, right? It's almost like you're wearing Kevlar if you've got enough vitamin C. So your self cells are well protected. And this just shows you. So the orange, the vitamin C antioxidant molecule, yeah, it's donated an electron to that unstable green guy with the unpaired electron, but it stayed stable. Meanwhile, it protected the blue cell from becoming unstable. That's how micronutrients and antioxidants work. The small molecule antioxidants. Vitamin D, D3 in particular, very, very important. I'm sure you've all heard this, you all know this. People that are low in D3 tend to get sicker faster, sooner, and not get well as soon as they should. And we've linked a number of illnesses. Here's an image of breast cancer rates. We've linked a number of problems to D3 levels, right? Either from solar exposure levels, or they've actually gone in and measured D3. Now, some of this has been causal. A lot of it's just correlated, meaning we see a link, but we don't know for sure if low vitamin D3 is why people get cancer, but we do know there's a link. D has a receptor on your innate immune cells. So remember the first line responders, they respond to D3. So they actually have a receptor dedicated to D3. So it's hugely important in their function. They stimulate, or D3 stimulates the cell growth and the cell functionality of those innate immune cells. Remember the neutrophils, the basophils, the natural killer cell. And then they protect from cytokines. Cytokines are proteins that can be either damaging or helpful, depending on which cycle of the immune system you're in. And they also regulate these two little proteins or proteases, enzymes, that directly kill pathogens. So if you're low in D3, your white blood cells are just not going to function optimally, and you're going to be more prone to problems of abnormal cells like cancer and pathogens and infections and injury. Vitamin A, this is your retinoids and your carotenoids, again, maintains wall function. So the first line of defense, hugely important for us. It maintains functionality of the cells that produce the mucus, that passive defense. And then for just the normal everyday function of these innate immune cells, your vitamin A is hugely important. And then beta carotene is used by your body to actually make vitamin A. You don't have to take vitamin A if you're taking beta carotenes, in other words. And you get that from the orange sort of pigmented vegetables, sweet potato, carrots, things like that. So vitamin A is hugely important. And then vitamin E. Remember I told you vitamin C is water soluble? Vitamin E and A are fat soluble. Vitamin E in particular is probably your most important fat soluble. Again, produced by your own body. And if you're taking in enough vitamin C and other antioxidants, they actually help vitamin E to recycle itself. So you can maintain proper levels of vitamin E, which protects that lipid bilayer, the cell wall. So vitamin E is going to protect the cell wall from the oxidative stress of the immune system and help the cells to function better. And then also it's going to be recycled by the small molecule antioxidants on either side of it. So as long as you're protecting the cell membrane and protecting the mitochondria, you're going to have a high functioning white blood cell. Vitamin E helps you to do that. And then B6. Now, the B vitamins are important in general because they're involved in a lot of the DNA functions and cell, I guess, manufacturing processes. B6 has been shown to help regulate inflammation, as has B12, and it has a very large role in natural killer cell function. So it helps in that recognition ability of a natural killer cell to hopefully not attack a self cell. Like, let's say you've got, I guess, a cut in your muscle in your hand, and you want the natural killer cell to eat up all the surface bacteria and the damaged cells, but you don't want it to go attack a muscle cell and chew that up. And then B6 helps provide what I think of as like the uniform of good cells. So as long as, this is why militaries wear uniforms, right, and teams, so you can recognize what's self and not attack them, and then pass the little ball around within your own team, the cytokines or the complements or the messengers, and then hopefully win. But if you start helping the other team, or worse, attacking your own team, you're probably going to lose the game. All of these things play together. Okay. So the innate and the adaptive immune system. So we've mostly talked about innate. We're going to sort of transition to adaptive now. This is your memory system, the one you develop as you grow. So when you're a baby, you don't really have an adaptive immune system. You get it from your mom's breast milk, really. And then you start to develop it on your own. Mitochondrial health is hugely important for both of these. These are images of the mitochondria in the bottom right. The mitochondria is what I call the refinery or the engine of the cell. So it takes your food products. So you eat food, you form glucose or whatever from the food, and then that drops into the mitochondria, and then through the electron transport chain on the cell wall in the mitochondria, on the membrane, you develop ATP, which is our form of energy that we're able to use. So you refine food into ATP, just like refineries refine crude oil into usable gasoline. That's what the mitochondria does for us. It's foundational to all aspects of health. Your immune system will not function if your mitochondria are not at 100% and optimally functioning. This is why antioxidants are important. Maintaining low levels of chronic inflammation is important. Stressing the mitochondria through exercise, intermittent fasting, things like that, so they can clean up the debris and get rid of bad mitochondria. Very important. What mitochondria can do in terms of when you get injured, like you're cut, let's say you're shot, let's say you fall and you break a bone, or you get infected by something, they actually will trigger what's called pattern recognition receptors, or PRRs. And these recognize little fragments of molecules that are known to be damaged. So a pattern recognition receptor will be able to recognize altered proteins or damaged cells, or worse, pathogens. And then that triggers inflammation, and that triggers innate immunity and starts to tell the complement system to come in and do its thing. And then eventually we're going to get out to the adaptive immune system. So mitochondrial DNA is one of these key features. So if your mitochondria fall apart, release their DNA, you're going to trigger innate immunity to come in and clean it up. But eventually you got to figure out a way to smoothly transition from this attack and cleanup mode to a rebuild and make your tissue normal mode. And that transition is what gets messed up with immune function problems, like autoimmune functions like lupus and rheumatoid, things like that. There's not that transition. So diabetic foot ulcers are a prime example. They never get out of that first phase, and they never get to the point where they can heal.
think someone's asking what's the best supplement you would recommend to enhance it. So I'm imagining the mitochondria.
Okay. We had a question, what is the best supplement you could take to enhance it? So mitochondrial health, I'm going to presume that's what the it is in that question. I think a series of antioxidants are necessary for the reasons we talked about. You need to have the small molecule antioxidants that clean up the cytoplasm or inside and outside of the membrane. And then you've got to have the antioxidants that focus on the membrane. And then things like CoQ10, which I think the asker just specifically asked about. CoQ10 is actually vitally important to transport electrons. So your electron transport chain does not work without CoQ10 to move electrons around. And it is in and of itself also an extremely strong antioxidant, obviously, because it can pick up electrons. So I would say CoQ10, hugely important for mitochondrial health, along with your vitamin C, your vitamin E's, your beta carotenes, and different flavonoids and other phytochemicals. Anything you can do to reduce oxidative stress to the mitochondria, you will be doing better. All right, so we've got our pattern recognition receptors. We talked about that. We talked about our smooth transition from attack, first responder mode to a more targeted special ops type of defense to then rebuilding. Okay, so now we talk about adaptive immunity. This is our targeted. T cells and B cells. T cells are what we call cellular immunity. B cells are humoral or blood-based immunity. So this is how we learn. This is how we actually become immune, like you develop immunity. Oh, I'm immune to that. I had it when I was a kid, sort of a thing. It involves the interplay between antigens, which are little pieces of protein from bad cells or bad pathogens, and antibodies. This is what your B cells produce to recognize the antigens, to know something bad is going on, and to trigger the defense mechanisms. That's a B cell there, the little blue guy with sort of the teal center, and those are the membrane-bound antibodies. Now, some B cells will actually let go of the antibodies, and the antibodies themselves just float around in the bloodstream. And then when they recognize an antigen, they then signal attached to a B cell, and the cascade begins. So this system can only develop with exposure to pathogens, okay? Unless you're walking around and breathing in viruses, getting touched by bacteria, et cetera, you're never going to develop an immune system. It has to have exposure, okay? And then the picture on the right is just a little bit more focused of the light chains and heavy chains of an antibody and the antigen binding site. So there's a gazillion different types of antigen binding sites, all coded by DNA. But they aren't going to develop unless the antigen actually presents itself and primes the cell. Okay, we got a question. I'm going to have a sip of tea while we go.
In the advice on restoring I, little g, big G, and IgA due to B cells being destroyed by chemotherapy for lymphoma.
Wow. It was a very complicated oncology-based question. I'll do my best. Cheryl asked, any chance of, or what would help restore B cell function specifically?
Well,
Oh, the IgG and IgA. So those are, yeah, the B cells are destroyed from chemotherapy, from lymphoma. And then the circulating immunoglobulins, the IgGs, IgAs, IgEs, et cetera, IgM, are depleted. I think the only way to restore it, and you probably have to talk to your oncologist about this, is you have to basically just give your body the micronutrients it needs, because the human body has an amazing ability to adapt and overcome. And things are still there in the bone marrow to help produce these cells, right? That's where they all start. The B cells and the T cells are formed in the bone marrow from progenitor cells. Now, some people are big believers in stem cells for this type of a problem. So you put virgin stem cells in, and then they become B cell forming cells. But again, you're going to have enough circulating memory cells in the body to be able to get back to the level you were, right? Otherwise, you got to start exposure. But I'm going to presume that there's enough normal B cells left that would be possible. Stem cells, of course, are extremely controversial and not used a lot in this country for issues, but they do have a pretty good track record in other countries, and they're starting to do more and more studies. So that's more of an oncology question, but I would say you just got to give your B cells what they need to do their thing, because the human body will do it for you. Oh, the micronutrients, sorry. So I'm talking about your vitamin C's, Your D3, very, very important. Quercetin, coenzyme Q, anything that promotes mitochondrial health, because your cells can't function without energy. Your beta carotenes, any of the flavonoids or bioactive antioxidant phytochemicals like CBD, things like that. Really just to, yeah, the anthocyanins that are in tart cherry and also other berries like blueberries and blackberries. All of these things will just kind of maintain a stable mitochondria and stable cell and give it the functionality, the coenzymes that they need to perform cell function. So like zinc, magnesium, very important because those are cofactors in hundreds of different physiologic processes of the cells, to include the immune cells. A lot of people forget the minerals. Go ahead. Okay, so is your adaptive immunity forever? Probably. Of course, this is debatable in some circles, but most of us don't worry about catching the cold we caught last year but you know what happens is a new virus comes around and you're just going to catch that cold. But our system is very, very strong about responding to these. The first exposure to an illness is going to be a weak kind of a response. You're not going to do that well against it, but you will fight it off in most cases. But once the immune system is primed and we've got memory B and memory T cells rolling around, then the second exposure, it's like you just get hammered. This is sort of like, think of it like a military. They get attacked once one way. They develop strategies and defense systems to protect against that more robustly the second time around. Just like football teams. If you see the same play over and over again, obviously the defense is going to adapt and be able to attack against that play. So the first time you run that play, you may get lucky, but the second and third time, you're probably going to be stopped. Okay. All right, so B cell immune function. You've got naive B cells, meaning they have not been exposed to an antigen. They mature only when exposed to an antigen. Otherwise, they just sort of disappear eventually. Memory B cells, again, membrane-bound antibodies that have developed since exposure. And these guys are just floating around in the blood, thus your humoral immunity, waiting for that antigen to present itself again so that they can attack and kill. The effector or the action B cells, these are plasma B cells. These are when your antibodies are free floating. They find the antigen, they bring it to a B cell and activate the B cell, which then effectively starts to kill the pathogen. And then they internalize the antigen with, the antibody pulls it in, signals to the immune system, the rest of the immune system, the innate and the T cells through chemotaxis. Chemotaxis just means chemical information. So B cells can't pick up a cell phone and call a T cell, but they can send out chemical messengers is what they do. And then they all work together to destroy the pathogen. But the first phase is still going to be effective. They'll quickly develop an antibody and do all of this. It's just much faster that second time around. Yeah, we can take a question.
Stem cells. This poor lady has rheumatoid, osteoarthritis, and plantar fasciitis in her ankles and feet, which is miserable. She had to give up her career as a hairstylist.
Okay.
But with stem cells.
This is somebody who's a hairstylist that has rheumatoid and has a lot of pain in what sounds like the lower extremities, in particular, plantar fasciitis, for example. Wants to know if stem cells will help. The short answer is I personally believe stem cells could possibly help everything. Because if you put them in correctly and in the right environment, they will become the progenitor cell of whatever that substance is. For instance, I inject them in knees sometimes, and then in theory, they should become cartilage-forming cells. We inject them in tendons, they should become tendon-forming cells. We use them in orthopedic surgery all the time to help promote bone growth. We usually extract it from somebody's bone marrow, centrifuge it, pull out as many of what we think are stem cells, put it back in the bone, and it becomes bone forming cells and helps promote healing. So stem cells are great for improving healing, but you got to have the right building blocks in your system in terms of health and wellness for the stem cells to work properly, because just like any other cell, you can't just put them in a depleted environment with no micronutrients and expect something different to happen. Stem cells in conjunction with a good diet and a good healthy regimen and stopping smoking and such will work well. And I've used them a fair amount. And when I say stem cells, technically I'm supposed to say medicinal activated cells or mesenchymal progenitor cells. The FDA doesn't want anybody really using the term stem cell. So think of it more like progenitor cells based on whatever material you're in. There's other things you can do too, though. Platelet-rich plasma, connective tissue matrix injections derived from amniotic membranes after donated bursts. They function in a similar way because they induce all of these healing cascades through proteins, through chemotaxis, and you don't even really have to have the stem cells. So sometimes it's a little bit more affordable. But yeah, I mean, obviously without examining and seeing blood work, et cetera, it's difficult to answer that. But generally, stem cells are effective for a lot of different issues. And the healing soul. Thank you, whoever said that. All right, moving on. All right, so you probably heard in the news so-called monoclonal antibody treatments. So that is when you take those circulating antibodies, right, from the plasma B cells, and you actually put them in the bloodstream. So let's say I got chickenpox, and then I developed antibodies to chickenpox. Somebody could take my blood, filter out those antibodies, right? And then let's say Joe over there never had chickenpox, but he's going somewhere where it's endemic. And so you would put my antibodies in Joe, and all of a sudden he's got humoral antibody or humoral immunity against the chickenpox, because the little antibodies are going to sense that pathogen, go to his B cells, and then turn them on and develop his own memory and T cell cellular immunity. Okay. So these can actually be moved from person to person to person. And then they can be made in the lab and then injected into people. That's what you're hearing about with this monoclonal antibody system. It's just harnessing the capacity of the human immune system and using it in a little bit of a different way. So basically the antibodies mark a pathogen for destruction. So you can like give yourself a hyperimmune response. Remember that secondary response? It's much faster, much more powerful. You can skip that whole first response and get to that second response by taking monoclonal antibodies. So the T cell, the cellular immunity. So B cells directly recognize antigen or pathogens. T cells recognize cells that have been infected or damaged. So once the virus has gotten into a cell, it's a little bit too late for the B cells to act at that point, and it's too late for the innate immune system, because usually at that point the infections become overwhelming. So at this point the T cells come in and help out. And they are made in the bone marrow, but developed in the thymus. And in the thymus, they learn. So they learn to recognize self cells and non-self cells. And they do this because everybody's cells produce these things called MHCs or HLAs, which are major histocompatibility complexes. When I was a resident, we usually said human leukocyte antigen or HLA. Like people with ankylosing spondylitis are positive for HLA-B27, for example. So that's an autoimmune disorder. So if you're positive for this certain MHC or HLA, the T cells begin to attack the self cells. So basically the MHC2 and the MHC1, so complex 1, complex 2, will present an antigen to the T cell. The T cell says, hey, that's not human, that's not Meredith, I'm going to attack it. Or the cell will present something that says, hey, don't attack me, I'm part of Meredith, please don't hurt me. And the T cell moves on. What happens with lupus, rheumatoid, psoriasis, ankylosing spondylitis, all these autoimmune disorders? The T cell loses the full ability to recognize self or non-self. All right, next. Okay, so again, T cell cellular immunity is your concept of self-tolerance, the opposite of autoimmunity. So if you've got perfectly functioning immune system, you're never going to attack yourself. You're going to have a perfectly functioning system that says pathogen damaged cell, get rid of that. Okay, good, that job's done. We're going to shut down, moving on to the cleanup phase, and now we're moving on to the rebuilding phase. If you don't have that, you're just never stop attacking. That's the problem with chronic low-grade inflammation in our systems. T cells, you've got your helper T cells. So the helper T cells have this certain receptor on them called CD4. That activates all other immune cells. So it gives you a more robust, enhanced ability to kill pathogens and fix injured cells and get rid of cancer cells. And then you've got your cytotoxic or your killer T cells. They have a representative on their surface called CD8. This is what's actually going to go in and kill cancer cells or tumor cells, which are non-self, right? And then they're going to kill pathogens and infected cells. And then to help to regulate the helper and the cytotoxic T cells and keep everything running smoothly, sort of I guess sort of like the police of the system are your Tregs or your TREGs, your T regulatory cells, and they express CD4 and CD25, and that is what lets us really distinguish self and non-self. We have a question?
What do you think about the research for CoQ10 helping kill cancer cells?
What do I think about the research for CoQ10 specifically to help kill cancer cells? I'd have to see that paper. I haven't read that paper specifically. I would say that CoQ10 being one of the major electron transporters for the mitochondria, I would assume it has something to do with that functionality as opposed to a direct activation. What they're doing now in cancer is they're turning off, how do I explain this? There's something called a checkpoint inhibitor, and it keeps cancer from disguising itself. So one of the problems with cancer and tumors is they will secrete signals that trick T cells into thinking that they are part of me. Like, let's say I had cancer and the tumor in me would disguise itself and it would look like Meredith, so it's wearing the wrong uniform. And so the T cells bypass and the cancer keeps growing. Well, there's a checkpoint inhibitor that can stop that disguise. It's like turning off the cloaking device of a Klingon ship, okay, if you're a Star Trek fan. So cancer will cloak itself. Well, the checkpoint inhibitors come in and uncloak it. So that's one way we're harnessing the T cells to fight cancer. Specifically for CoQ10, I don't know, but I would love to read that paper. Okay, autoimmune. We've talked about this. When your innate and your adaptive self-recognition ability fails you, that's when you get autoimmunity, okay? And you start to self-attack. Now, interestingly, AIDS or HIV is a whole nother problem. That's when your CD4, your helper T cells are completely dysfunctional. And so you can't harness an immune response really for anything. You may have a little bit of an innate response initially, but your cellular immunity is just completely defective. And so infected cells can quickly overwhelm the system. Because remember, the B cells aren't going to protect you from infected cells, only the T cell does. So without an appropriate number of CD4 helper T cells, you can't function. You can't have an immune system. And that's why that virus is so devastating, or used to be, because now we have enough meds that target it that we can make. It's really just a chronic disease now. Go back one. Yeah, sorry. And so the CD4 and the 25, the Treg cells, when that system, the T regulatory function gets screwed up, that's when you develop things like rheumatoid arthritis, psoriasis, et cetera. We discovered the HLAs, the major histocompatibility complex molecules, about 40 years ago or so, which is like baby land in terms of science. We're just now fully understanding them, but already using them as immune therapy for things like cancer. So hopefully we'll keep going with this. Okay. All right, what else can impact your immune health? We've talked about the micronutrients. You've got the basic understanding of the innate and the adaptive, and for the adaptive of humoral and cellular immunity. What else can you do to help your immune system besides take D3, C, quercetin, CoQ10? Well, you could sleep better, reduce your level of anxiety. Anything that happens in your system that increases your stress hormones, your cortisol, is going to make your immune system less robust. So anxiety, lack of sleep. We've talked about vitamin D. Smoking, of course, is probably one of the worst things you can do for your body. But for some reason, people are still doing that. If you do smoke, I would strongly suggest you quit. Oxidative stress, and that can come from diet, usually. Anxiety, lack of sleep can cause oxidative stress, and then pollution, things like that. And then lack of micronutrients, we talked about that. Diet is hugely important in immune health. Okay. Now, on these slides, I put in some fun old ads that were allowed before. You know, high fructose corn syrup is still allowed for some reason, a lot of things, as are trans fats at certain levels. But these ads cracked me up. The fat time of day. So this is how the sugar industry used to promote their sugar, pure sugar products, saying when you're hungry, eat something sweet and it'll help you not be hungry, so you'll get thinner. That didn't turn out to be so true. And then this other one says, if sugar is so fattening, how come so many kids are thin? Obviously, this was an ad from probably 20, maybe 15 years ago, because unfortunately, something like 35 to 40% of the children in this country are obese right now and are starting to develop atherosclerosis and diabetes before their teen years. So thanks to these ads and I guess just doctors, which
The
thing?
last one, the second paragraph.
The last sentence on the second paragraph. Now, what's one important carbohydrate? Sugar.
Yeah, it's sugar. It's not just good flavor.
Oh yeah, sugar. It isn't just good flavor, it's good food. Okay, so these were okay with the government before, totally cool. And that's, we started shoving sugar down our throats and wondered what happened to our immune system. All right, next slide. So I don't know what happened here, but I think a brand name got blocked out. This is high fructose corn syrup. You can find it at your grocery store to add to a variety of different baked goods, if you will. I wouldn't recommend it because this high fructose corn syrup, fructose will trigger a lot of inflammatory cascades in your body that are not so good and will help you form more advanced glycation end products, which I personally think is one of the fundamental issues with our diet. And we're working on a book to talk about that more. Excess energy states and hyperglycemia. So if you've got excess sugar running around your system because you made icing with this high fructose corn syrup, or you added it to something to brown your meat better or whatever, you'll have more of these monster proteins, I call them, the advanced glycation end products. That's when free sugars attach to amino acids and create an altered protein that goes on to destroy other things like DNA, white blood cells, immune cell function, mitochondria, creates more oxidative stress and more inflammation. And this, of course, will damage your immune cells. And then by way of damaged mitochondria, your immune system is depleted. So hyperglycemia is one of the big problems. Unfortunately, we're just now figuring this out. For years, we've been saying not only is this stuff not terrible, but it's good for you. Well, that's not really true. Yeah, sugary soda may be one of the worst things you can do for yourself. Okay, so the diet matters. What you are, what you eat. So if anybody had your mom tell you that, she was not lying. Okay, I love this ad, meat for the convalescent fighter. Obviously, this must have been during World War II or something, promoting eating processed red meat as a way to improve your immune system. When you look at the studies, population epidemiologic studies of diets and effect on health, my belief is, and a lot of the literature would support me, that the Mediterranean diet has one of the best track records in terms of reducing incidence of cancer, reducing incidence of long-term chronic illness and autoimmune dysfunction. So the Mediterranean diet is wonderful for immune health. Why? Probably because it's not a hyperglycemic diet. It's a very anti-inflammatory diet, and it's packed with the micronutrients you need. Other things like the blue zones or the Okinawa Japan diet, all similar concepts, very anti-inflammatory, low in glycemic burden, whole grains, micronutrients, and not a lot of these red processed meats that induce inflammation and have what in them? Advanced glycation end products. So any diet that avoids adding tons of advanced glycation end products is better for immune health. So I would say what you were taught years and years ago is not true, and we're just now figuring this out, or more likely just now admitting it. Next. So I talk a lot about taking antioxidants and supplements, and I'm a huge believer in that, but you really want to eat as good as you can and then supplement on top of that. Okay, so if you have a crappy, terrible diet and you're eating a lot of processed foods, high fructose corn syrup, a lot of sugar, you're smoking, you're stressed out, you don't sleep, you are damaging your barrier. All your skin's messed up, your GI lining's messed up, your gut biome's not creating the right neurotransmitters and the right messengers, your IgA, your IgE, all your immunoglobulins are shot. You have no ability to fight off that first infection. You can never go when that smooth transition to the healing phase. And all of this is because of just horrible food you're eating. The inflammatory diet will promote autoimmune. I have a lot of patients who, when they switch their diets and either become vegetarian, pescatarian, vegan, or to the Mediterranean from a normal Western diet, a lot of the symptoms of their autoimmune disorders just go away without taking any extra pills or having to go get an IV infusion that costs $6,000 a month or whatever. An inflammatory diet, let's say you eat bologna sandwiches on bunny bread or Wonder Bread every day with a lot of mayonnaise, you are promoting oxidative stress and mitochondrial damage by virtue of the refined sugars. the high heat processing of those foods and the high levels of advanced glycation end products and the lack of micronutrients in processed foods. And so your diet is basically taking away bullets, taking away weapons, taking away technological know-how, taking away Kevlar and helmets from your army, and leaving your immune system with really just sticks and stones. So this is what you don't want to eat: processed, highly processed foods, okay, ultra processed foods, for the reasons we just discussed. And then also because a lot of these have actual toxins in them. Now, some people will call sugar a toxin, glycotoxin, which it probably really is. But you'll have actually cancer-causing agents found in smoked meats and highly processed meats. Acrylamide is probably the most famous of these. And that'll just form in your meat when you're cooking it on the grill, honestly. And then they just have really high levels of these dietary advanced glycation end products. So not only does your body make them in a hyperglycemic atmosphere in the blood, but if you eat them, your body will absorb them, and then those go on to attack the DNA, attack the cell, attack the mitochondria, and destroy cell membranes, and cause dysfunction of your immune system. Was that a question? Next. Somebody said, don't take away the charcuterie board. Look, everything in moderation, even moderation. I think if you're generally healthy and you're generally self-protective and do the right things, periodically, if you have to eat a charcuterie board, go for it, because your system should be able to handle that. All right, environmental toxins. Let's talk about that. I am in Louisiana, which is really Cancer Alley, in my opinion. I'm surrounded by chemical plants. The way the chemicals are regulated in this state are not cumulative. It's rather, oh, you're only producing that much of that chemical, you're okay, meaning in the air. Oh, you only make that much of that chemical, you're okay. But they never add up chemical 1, 2, 3, 4, 5 to the overall burden and see what it does to us. So we're constantly exposed to pollution here. And a lot of you out there are really. Anybody that smokes is self-polluting. Anybody that vapes is self-polluting. I recommend marijuana to people all the time medically. It's got awesome medicinal profile and it's extremely natural. But I really try to keep them away from the inhaled ones because we don't know the cancer risk. No one's been allowed to study it. I have to assume it's going to have a cancer risk. And I counsel people on that. Metals, heavy metals exposure, okay? And I test people for metal toxicity periodically. We talked about cigarette smoke. You guys all see the attorney ads for asbestos. Pesticides and herbicides, those ads run all day long too. And some of these associations are correlative and not truly causative. We don't really know. But in general, we should avoid chemicals if at all possible. Why? Because they damage the mitochondria, damages the immune system. You can't have a good immune system, then you can't fight off cancer, you can't fight off infections, and you certainly can't self-heal. Takes longer to heal bone breaks, takes longer to heal skin breaks. You could develop an autoimmune disorder, you get diabetes, et cetera, et cetera. So trying to avoid environmental toxins, or if you can't, taking a lot of antioxidants to protect yourself from it, and metal chelators, things like chlorella helps to get heavy metals out. Alpha lipoic acid helps to get heavy metals out. That's what I do because I'm not moving anytime soon, so I need to protect myself from environmental exposure. And here's another ad for you. DDT is good for me. How about that one? That's not been proven to be good for people. Oh, we have a Saints fan asking about smoked turkey legs. Are they bad? I don't know if she's a Saint fan. This is Joy. Yes, the short answer is smoked meat is probably filled with dietary advanced glycation end products. The way you can reduce the number is to marinate in an acidic environment before you cook the meat. That is one thing you can do. So, marinating in some sort of citrus or vinegar type solution before you cook the meat can be helpful. I try to cook on low heat, high humidity environments as much as I can now, or boil or stew or make soups, because also the level of fluid when you're cooking the meat also reduces the advanced glycation end products. But if you're smoking a turkey in like a high heat, high smoke environment, I'd probably take a lot of antioxidants when I ate that. All right, so we talked about healthy diet. We're going to talk about exercise briefly. We talked about reducing stress to reduce your cortisol levels, and rest and sleep. That's when your body really cleans out bad cells, tightens up the mitochondria, fixes cell membranes, gets rid of toxins. So sleep is really, so anybody in Louisiana probably knows somebody that works at a plant, and the plants have these so-called turnarounds, and that's when the plant gets shut down for a couple weeks and all the maintenance happens so that it can then go on to run 24 hours a day, 365 days a year to produce whatever product it's making for the rest of the country. But without those time periods of maintenance, the whole place would fall apart. So think of rest as your nightly turnaround where your body maintains the plant so that the plant can keep going the next day. Yeah, we're good. Go on. Okay, don't smoke. If you get anything out of this, eat a lot of vitamins, take some antioxidants, try to avoid processed meats, but definitely don't smoke. This is showing normal mucus in the top with the cilia, kind of grabbing little pathogens and helping the cilia smooth. The cilia do this all day long, and they just kind of like push badness out. That's why you have snot. That's why you have earwax. That's why you're always got phlegm and stuff. Your body's trying to get stuff out all the time that you're breathing in just because you're alive. Smoking makes it dysfunctional, and the mucus just sits and coats everything. And this happens particularly at night. And this is why smokers all have that terrible smoker's cough in the morning, because all of their respiratory linings get coated with this gunk that they don't have normal cilia function to get rid of. And then they wake up and they start moving, and they got to get all that gunk out at once. So if you hear that smoker's cough, you can pretty much be sure that that person has a dysfunctional immune system because they've lost their barrier abilities. And it's toxic to the leukocytes, or the white blood cells themselves, and smoking is highly correlated with increased levels of oxidative stress or reactive oxygen species. So this is a modifiable risk factor in medicine speak. You can modify this risk factor by quitting. Exercising. Iced tea is a good antioxidant. Skeletal muscle is not just muscle. It is also an endocrine or hormone sort of an organ and a metabolic organ, extremely involved in pulling sugar out of the bloodstream. The reason exercise helps diabetics is it's not insulin dependent. So let's say you had zero insulin in your body and you went for a run. Your body has glucose receptors in the muscle that will pull sugar out of the bloodstream without insulin. And exercise induces them or upregulates them and gets them to function. 30% of your resting metabolism is skeletal muscle. So the more muscle you have, the faster your metabolism will be. During intense exercise, it is 90% of your metabolism, meaning your body pulls energy from other systems, of course. And we're going to talk about one of the issues with that in a second. But basically, exercise is one way to reduce that hyperglycemic burden, get fructose out of the system, get glucose out of the system. And then working muscle helps to clean up the mitochondria because you're stressing the mitochondria. And just like mushrooms only grow if they're stressed, right? You got to make them humid and then make them dry, got to make them hot, make them cold, and then all of a sudden they start to grow. That's how your mitochondria are. They do better if they're stressed periodically. That's how intermittent fasting helps health. So exercise will lead to more and better mitochondrial mass. So you'll build more mitochondria and you'll get rid of the damaged one. So you have better mitochondria and more of them. And then it upregulates all of the antioxidant defenses of your system. Exercise is very important. And we talked about diet and exercise last month. You don't have to go join CrossFit for sure. You just got to take some walks a couple times a week and then do a little bit to make sure you stay strong. Okay, again, remember in the beginning, I told you everything about immune health comes down to mitochondrial health. Well, that's true. If you've got efficient cellular refining systems and less oxidative stress, your white blood cells are going to work better and more effectively. Your T cells will work better. Your B cells will work better. Now, remember I told you that 90% of your metabolism goes to your muscle with intense exercise. That means your body's pulling them from other areas. Well, one of them is the immune system. So if you're doing super high intensity exercise, or let's say you run an ultra marathon, why you would want to do that, I'm not sure. Let's say you run 50 miles, 100 miles, you will be temporarily immune depleted after that. But long-term, you'll be better off with your immune system. But high extreme bouts of intense exercise do deplete the immune cells from functionality short term. And they've studied elite athletes to figure that out. But over time, regular, moderate, normal amounts of exercise will actually improve your immune self by making the mitochondria better, helping reduce oxidative stress and inflammation. There was a study where they looked at elderly women, which I'm probably in that group now, and we reduced infection duration by about half with just 5 45-minute walks per week. And this wasn't speed walking, not like the Olympics where you watch them speed walking and you wonder how it's humanly possible. I still haven't figured it out, and I've tried. If you do try speed walking, I would not let anybody watch you try it. But elderly women, just a basic walk with your buddies. Go take a walk with your buddies, chit chat, talk about the blog or the latest book you read. 45-minute walks, you don't even really have to do that. A lot of studies say 30 minutes. You can reduce infection duration by 50%. Add a little bit of vitamin C and D3 to that mix, and guess what? You're really helping yourself out. You will have better white cell response. You'll have better mitochondrial function. Your natural killer cells function better, and you get rid of all the detritus in your system and detox. Is water, okay, the question is, are water aerobics worth exposure to chlorinated chemicals? I would say that pool chemistry is so hyper-regulated at this point that you don't need to worry about chlorine poisoning the way you would at a chlorine that has a leak. So yeah, I would say the benefits of exercise from water aerobics, and also the benefits of water. Water in and of itself is healthy. And then also if you have arthritic joints and you get if you're sort of waist, you've offloaded the lower extremity joints 60%. If you're chest high, you've offloaded about 80%. That have pain but need to develop muscle and need to exercise, water aerobics is a great option, and I think vastly outweighs any potential issue with the chlorinated water. All right. What's that? Oh, okay, sorry. So a lot of the micronutrients we've been talking about and different functionalities of cell health and reducing oxidative stress and chronic inflammation, this is something that I'm deeply, deeply interested in and been trying to get my patients' minds to wrap around this and try to help them understand how important this is. And in the process of doing that for the past 10 years or so, we founded this company, The Well Theory, and we make these products, and they're all specific. In my opinion, I formulate all of them, come up with everything, work directly with a factory myself. And my goal is to reduce chronic inflammation, give the needed cofactors like zinc and magnesium to help immune health and help overall functionality, and then mitochondrial health, and then to reduce oxidative stress. And that means you got to put things in your body that pull that unpaired electron and make it stable so it doesn't go and destroy cell membranes and DNA. And then, of course, another big part of this is going to be to reduce the impact of the advanced glycation end products, which is something I'm working on right now. So we have a variety of products: CoQ10, vitamin C, quercetin, D3, zinc, magnesium, and all of it, you notice, they have a theme of improving mitochondrial health and reducing oxidative stress. Question is, can I explain what oxidative stress is? I can. There's actually another talk I gave that you should be able to access through, I guess, the Facebook page, specifically on my website. Sorry, which website? Warner Orthopedics or the Well Theory website, thewelltheory.com. Find the talk I gave on just oxidative stress. That is a huge topic. Or oxidative phosphorylation, I guess. Oxidative stress is when you have too many unpaired electrons running around damaging things. Now, what do I mean? So we are electrical beings and we make energy. We make energy by transporting electrons, and every time you move an electron, a bit of energy is released. The body harnesses that bit of energy and then creates usable fuel for us from it. Why do we breathe oxygen? Or maybe the better question is, this all developed in the environment of oxygen in our atmosphere, right? So oxygen is our final electron acceptor. So at the end of the electron transport chain in the mitochondria, when you're moving electrons up and down to create ATP, adenosine triphosphate, which is our primary fuel piece, the final thing to accept the electron is oxygen, which then forms water. So in the beginning, the oxygen will glom onto some carbohydrate and form CO2. So we breathe out that waste. And at the end, Water is the final product, so we urinate out that waste. It's all sort of this amazing interdigitated system that all makes perfect sense when you think about us developing on a planet with oxygen in the atmosphere. So the electrons move around, but sometimes there are unpaired electrons as a byproduct or the exhaust out of the refinery. Those then want a pair. No electron likes to exist alone. It's just a law of nature. So they will find a free electron to grab onto. And if you don't have antioxidants in the way to grab onto it, or like CoQ10, which loves to grab onto electrons, or say vitamin E or vitamin C, or the flavonoids, which are very strong antioxidants. These are the plant phytochemicals. If they're not in your system and in the intracellular environment, then the electrons will attach to DNA, they'll attach to proteins, they'll attach to the cell membranes, and they basically just destroy the cell. So you know how you leave an apple out on the counter if you don't put acid on it, right? Like lemon juice, it browns very quickly. That is oxidative stress. Wrinkles are oxidative stress. Rust is oxidative stress. It's anytime oxygen mixes with a product and then the electrons go haywire without being controlled. Yeah, and oxidative stress goes hand in hand with chronic inflammation in the system to cause self-damage. So there's actually the newer theories of aging and disease are linking everything to oxidative stress and chronic inflammation. So we only age at this point because we can't manage the chronic inflammation, the oxidative stress, okay? People that eat really healthy diets, really beautiful Mediterranean diets, avoid smoking and exercise, tend to have much longer health spans. They're healthier, functional, happy, cognitively intact, doing everything they want to do well into their 90s and hundreds. Okay, so aging, sure, it happens, but it doesn't need to happen the way that you think about it. And it's all because of these unpaired electrons and inflammatory mediators running around attacking ourselves. And we do it to ourselves.
Let's discuss basic low-impact exercise for seniors stuck in the recliner.
Okay, this question is, what are some basics of low impact exercise for seniors stuck in a recliner? Okay, so if you were my patient, I would do everything humanly possible to try to get you out of the recliner to begin with, because sitting is maybe one of the worst things you can do to the human body all day long. So fidgeting, you could start fidgeting. Fidgeting is reduced all-cause mortality by 30%. So if you just sit and shake your leg when you're sitting in the recliner all day, or like, you know, bounce your heel or do anything, any kind of movement is going to help. Get a 1 or 2 pound curl bar and just start doing some kind of muscle work. Straight leg raises. What? Yeah, they make these little cycling things you can sit and do. Really just start to move. It doesn't have to be, you don't have to be bench pressing your own body weight to be considered to be exercising. You just have to move. So if you can't, like, let's say your knee arthritis is so bad you can't even get out of the chair, maybe get a home physical therapist to come in and help you. Maybe you've got a family member that's willing to work with you and help you ambulate around a bit. But even like laying in bed and doing a straight leg raise and working your quad is helpful. Anything is good. You got to have muscle to function, right? And you've got to have movement to help clean up the mitochondria and get all the glycemic issues out of your bloodstream. Glutathione and what? Oh, somebody's asking about glutathione supplementation. Glutathione is an antioxidant that we make in our own bodies. So a lot of the supplements I have help your body either recycle its own glutathione or make more glutathione. You can supplement with glutathione, yes. And actually, we do some IV treatments with that in my clinic for people that are really depleted, or like, let's say, before a tailgate or something like that. But really, if you're taking a host of the variety of small molecule and larger fat soluble molecule antioxidants, your body will make enough glutathione on its own, but you can certainly supplement it with it, yes. But that is one of the ones we make ourselves. All right. All right, we have a giveaway specific for the immune system, okay? The connective tissue multivitamin, which has zinc and magnesium, which we didn't talk about much in this talk, but those are extremely important to white blood cell function, as well as some D3, calcium, and vitamin C, high dose vitamin C, which we did talk about. And then we've got the D3C quercetin mix, which is, I take both of these because I was D deficient a few years ago. So I take a lot of D. I'm taking probably 8,000 international units a day right now. The multi has 3,000, and then you can add a little bit of extra with the D3C quercetin. Quercetin is a plant flavonoid. That's that phytochemical we've been talking about that is strongly antioxidant in and of itself. And it's got a lot of anti-tumor effects, anti-reactive oxygen species effects, reduced inflammation. Quercetin is an amazing phytochemical. Apple skins have quercetin, onions have quercetin, and it acts as a plant phytochemical flavonoid antioxidant for you. So this will be our giveaway for people who are watching the webinar today, and hopefully, you know, you got to take these things regularly to really build up your immune system. But I mean, rarely do I get sick anymore, which is really a nice thing.
Let's see.
Oh, between two people?
I mean, they're like both commenting. Joy and James.
Well, why don't we give them both? All right, we're going to give 2 away for good comments. Joy and James will both get this bundle, and hopefully get you started on the road to micronutrient supply to your leukocytes. So hopefully that kind of clears up the immune system. Maybe some of the talk on the news lately about certain viruses will make more sense to you, and talk about things like vaccines, which harness everything we just talked about, right? The body's ability to fight off pathogens. All vaccines do is harness the humoral and cellular immunity, okay? So maybe you'll understand it a little bit more, and hopefully I answered all your questions.
One quick one, Hannah.
Oh, we have another question, one more.
What are your optimal vitamin D level recommendations in blood work?
The optimal vitamin D recommendations in terms of when they check your serum levels of D. Well, first of all, hopefully they're checking, there's different ways you can check D. I check D25OH, which is sort of like the inactive form that floats around in serum. So if those levels are optimal, you can assume that people have decent active levels. You can measure the active levels too, but it's just not quite as accurate. So the government sets the range from 30, I think it's micromolar, 30 to like 50 is normal. But remember, that's just to prevent rickets, which probably nobody even knows what rickets is. But that's when kids grew up with bow legs and broke their bones because they didn't have any vitamin D. And that's back in the day when you were given castor oil to try to replace it. I think a lot of the literature, and I've written blogs on this, would actually suggest that 50 to 60 or even 70 to 90 is good for optimal health. When these levels were set, I don't think anybody really understood how important D3 was to every single thing in the human body. They were just looking at bone disorders to an extreme degree, and that's when these levels were set. But for optimal bone health, particularly for athletes that want to prevent getting stress fractures, like long distance runners, people like that, it needs to be 70, 80, I think. To try to prevent hip fractures and to live well and have a great immune system and good cognitive function, I think you need to be 50, 60, 70 easy.
Best supplements for ligaments.
The best supplements for ligaments. So ligaments are just connective tissue. So anything that reduces oxidative stress in the connective tissue and the fibrocyte and collagen level. So all the flavonoids like the quercetins and the tart cherry extract help. Turmeric is amazing for this as well. Anything that improves cross-linking, vitamin C, which we talked about. You probably get enough amino acids from your regular diet to give you the collagen building blocks. So I don't think you need to worry about that so much. Bone broth can add that, of course. And then anything that you just got to reduce oxidative stress. That's where a lot of the stiffening and sometimes there's too many cross links. You need to have just the right amount. So you have to reduce dietary advanced glycation end products and reduce their ability to glom into collagen. And that's your anything that reduces oxidative stress or those free electron pairs. So I would say the plant phytochemicals like quercetin, tart cherry extract, turmeric, vitamin C, And then, of course, the B vitamins, which help the DNA produce the collagen, okay? So B vitamin complex, which we have in a gummy form, I think. And then also coenzyme Q to assist your electron transport chain. And also, anybody out there with a statin with muscle pain, you should be taking coenzyme Q, in my opinion, because that reduces that statin-associated muscle pain. So ligament, you need to be on vitamin C, you need to move, you need to have proper flexibility, you need to reduce your advanced glycation end products and the oxidative stress caused by them, so a lot of phytochemicals to reduce that.
What is the best sleep product? I sleep less than 4 hours nightly.
This question is, what is the best sleep product because I sleep less than 4 hours a night? Well, I'm glad this person's asking because he or she should be sleeping 7 to 8 hours every night. That's just been shown study after study. There's no debating that anymore. Now you're going to have your outliers on your bell curve, right? Some people that don't need that much, some people that need more. But generally speaking, humans need 7 to 8 hours a night. What we did is we have 3 ways to attack the sleep problem. First of all, you should avoid blue light at night, have proper sleep hygiene, you know, a dark room, don't watch TV at night, don't read a bright Kindle at night, hydrate, try not to drink alcohol too close to bedtime, et cetera, et cetera. Let's say you did all that and you're still not sleeping. So we put together a gummy to help with sleep that has tart cherry extract, which naturally has a bit of melatonin, some GABA, which functions like gabapentin does by depressing glutamate, which is an excitable neurotransmitter. It's kind of what keeps your mind revving at night. So if you take GABA, that's a natural substance. It'll kind of calm that down. It's a calming sort of a molecule. And then either with CBD, which has been known to help the brain detox and also help with sleep, highly antioxidant, by the way, probably more antioxidant than C or E in some situations. And then we have one with tart cherry, GABA, and melatonin. And then I actually have a Delta 8 THC gummy out, which is extremely helpful with sleep. We can't really talk about that too much just because of rules, but I can talk about medical marijuana as opposed to Delta 8 THC. Medical marijuana is Delta 9 THC. I recommend that all the time and for chronic pain. And the number one feedback I get is people sleep better and then they hurt less. So, and that's because of the actions of the phytochemicals on the brain to assist with a detox. So I think proper sleep hygiene, stay on top of your hydration, and then things like melatonin, GABA, tart cherry extract, CBD, and or if you're in a state where it's legal, maybe medical marijuana might help. And then exercise. People that are active during the day and move tend to sleep better.
Okay. Is there a certain type of zinc that is best?
Question is there a certain type of zinc that is best? I'm sure there's people out there saying one type's better than the other. Ours is zinc gluconate. I mean, you can have whenever you take an element like a mineral, there's the elemental form and then there's the salt that your body can actually take in. I don't think any one is better than the other. You might need one for a different reason. For instance, with like calcium, certain calcium supplements are better for people that are prone to kidney stones, and certain aren't. We use zinc gluconate, but I think other salts are probably just as fine. If you want to eat it out of your diet, do you know what the number one food is to produce zinc for you? Is oysters.
Does turmeric affect high blood pressure?
This question is, does turmeric affect high blood pressure? I would say in the beneficial sense. Turmeric is very anti-inflammatory and pro-health, and it actually helps the gut biome a lot. And so people that take turmeric tend to have less pain and be healthier over time, and that will actually reduce blood pressure, I think. Now, are there any clinical studies, placebo-controlled, double-blind, like the pharmaceutical industry wants? No, not that I'm aware of, but I've never seen any studies that show it increases blood pressure for sure.
What's the difference between synthetic supplements and supplements from plants and fruits?
This question is, what's the difference between synthetic supplements and supplements derived from plants and fruits? I mean, really, at the end of the day, when you get down to the molecule, as long as you're making the exact molecule, there probably is not a lot of difference. If you're doing a single molecule supplement, let's say you're taking synthetic ascorbic acid, or you're taking vitamin C extracted from plants and vegetables, a molecule is a molecule is a molecule, because it's really just a collection of carbon, hydrogen, oxygen, nitrogen, etc. Attached to each other with either covalent or different kinds of bonds of electricity. But the difference comes in when the plant phytochemicals generally have what's called the entourage effect, where it's not really a single molecule, right? You get a whole panoply or a whole group of different phytochemicals that all work together. So like when you add holy basil to your spaghetti sauce, I mean, you're getting a ton of phytochemicals. When you season your Mediterranean salad with marjoram, you're getting a ton of phytochemicals. You're not just getting a single molecule. So I'd say the biggest difference is single molecule versus entourage effect. And then, of course, you want to wonder how your synthetic was made. What was the actual process done to do it? Did it involve solvents? Did it involve harsh chemicals? Things like that. I try to stay away from those, but some single molecules created in a lab are effectively the same thing. All right, last question, guys.
Do you have an opinion on bee pollen granules versus super bee complex vitamins?
Okay.
Maybe you don't have an opinion on it, but you can talk about it.
Okay, this question is, do I have an opinion on bee pollen granules versus a super bee complex vitamin? Honey, bee pollen, and wax are all filled with just a ton of different enzymes, minerals, and phytochemicals. I mean, honey is probably one of the healthiest things you can do for yourself. Bee pollen is extremely healthy. And there probably are a lot of B vitamins in there. But I think there's a lot of unknown or undescribed flavonoids and different little enzymes and whatnot that the bees produce and spit out into the pollen and the wax and the honey. And then the B complex vitamins, you need B vitamins for proper DNA function, proper nerve system function, and a variety of other reasons in your body. So we have a B complex in a gummy that has, 1, 3, 5, 9, 7, 12, all the B vitamins that have been named thus far, because they are extremely important. But honestly, if you could take both, I would take both. Have I worked with anyone with transverse myelitis? Yeah, that's just another, I don't want to say just another, that's a source of chronic pain, much like arachnoiditis or failed back syndrome. We have a lot of patients with these issues because when the medical system is done with them and spits them out, a lot of these people still hurt despite having had multiple surgeries, and they have these inflammatory conditions that involve nerves. Myelitis it means inflamed and irritated. So that drops you into the chronic pain world from chronic inflammation and oxidative stress. So I try to encourage people to get on an anti-inflammatory diet, do as much movement as possible, avoid toxins, sleep well, all the stuff we always talk about. And then take things like palmitoyl ethanolamide, that helps to reduce inflammation around nerve endings. Alpha lipoic acid is a wonderful antioxidant that's both water soluble and fat soluble, one of the only ones out there that will detox both sides of the membrane and the membrane itself. And that's particularly important for nerve health. It's very effective for diabetic neuropathy, for example. Medical marijuana, we've talked about, works wonderfully for people with failed back and arachnoiditis, et cetera. So anything that you can do to reduce your inflammation, I think would help your condition.
And then, somebody does, like, if people want to see you, if they can't visit you, how can they talk to you from different states?
Oh, somebody's asking how they can have a consultation from a different state if they're not in Louisiana. So there's a lot of rules about that when you have an MD. Like if I were not a medical doctor, it would be much easier. Like if I were a life coach or a health coach or whatever. But because I got my license, I am I can only talk to and offer advice to people where I have a medical license. Currently, that is Texas, Mississippi, and Louisiana. If I had more time or one dedicated staff person, I could try to get medical licenses elsewhere, but it's extremely difficult process with a ton of paperwork. So those are the 3 states. If you're in those states, I can do a telehealth consult, and we do that for people. All right. Thank you for joining us, and remember, Joy are going to get their little package, And hopefully this gave you a bit of foundational knowledge. So when you talk about all of the different issues with viruses and bacteria that we get hit with on a daily basis, you kind of understand the fundamentals now of the innate immune system, the adaptive immune system, complement, and how it all works together. And hope y'all have a great day. Oh, well, thank you. I always enjoy this. It's my pleasure.